Hello my dear students. In today's session we are going to discuss about one more important topic, that is operation with unbalanced rotor impedance. Okay, let me start the session now. See here, first we need to understand the motor performance, what will be the effect on the induction motor performance with the unbalanced rotor impedance we are studying now. See here, basically unbalanced rotor impedances were earlier days unbalanced rotor impedance, this is going to be mainly employed for the starting as well as the speed control of the induction motor. What purpose they were using in earlier days? The starting as well as the speed control of the induction motor, that is going to be done with the help of the unbalanced rotor impedances. Okay, but nowadays they are not in use anymore because of the reason that because of the development of the power electronic devices and different kinds of starters like a star delta starter, direct online starter, is it right? So there etc. So different kinds of starters have been developed. Then what might be the reason for this unbalancing occurs in the rotor impedance, in the sense that basically we know that induction motor, it is having the two main parts. So first it is stator part, it is there, one more it is rotor part, it is there, is it right? So due to any reason, if there is a loose contacts occur in the rotor circuit, means that results into a unbalancing in the rotor resistance or the rotor impedance. Okay, so this unbalancing in the rotor impedance or the resistance which causes the imbalance or unbalancing in the rotor currents also. Getting my point? So that is why it is very much useful to examine the effect of this unbalance on the induction motor performance. Okay, so that is the reason, that is why whatever the unbalanced occurs in the rotor current, that is IR, that is resolved into two components, symmetrical components. One it is positive sequence component, one more will be negative sequence component rotor currents. Okay, then what is the meaning of this positive sequence rotor current? Positive sequence rotor current means it produces the torque. Due to this positive sequence current, driving torque it is going to be produced, that is represented by TP. This torque will be same as that of the motor torque Tm. Okay. Next thing, it is one more important component, negative sequence component. Negative sequence component also produces the rotating field. This rotating field, it is going to be moves with respect to rotor at a speed of minus s omega ms. Omega ms, it is nothing but synchronous speed. Yes, it is nothing but the slip. Negative sign why I had taken in the sense that this rotating field, it is going to be moves at a speed in a reverse direction. That is why negative sign we have used here. Then the interaction between positive and negative sequence components. Getting my point? The interaction between the positive and negative sequence components produces the torque, so that whatever the torque it is going to be produces, that is of pulsating in nature, that is of pulsating type. So due to this pulsating nature of the torque, then what will happen? Due to the pulsating nature of this torque results into a motor torque. The motor torque, it is going to be reduces substantially. Getting my point? Due to the pulsating nature of the torque, the motor torque, it is going to be Tm, that is reduces. Getting my point? Due to the presence of negative sequence components, the motor torque, it is going to be reduces. If the motor torque reduces, means what will happen? The copper as well as the core losses are going to be increases substantially. So if the losses are more, means obviously the efficiency or the life of the induction motor, it is going to be reduces, right? So that is why this is the main effect on the motor performance due to what? Unbalanced rotor impedance. This is the curve drawn between speed as well as the torque itself. Omega m is the rotor speed and this is the torque. What I told here, this rotor current resolved into two components. One, it is positive sequence component and negative sequence component, and the by using superposition principle we'll get the net torque. Net torque will be the sum of what? Positive sequence torque torque plus negative sequence torque. Okay, so here in this case, let me consider two cases. In the first case, we'll consider for the slip value, the S value, if it is going to be varies between 0 to 0.5. So for a first case, for 0 less than equal to S less than equal to 0.5. In that case, what will happen? The speed, nothing but omega m of this negative sequence rotor field will be positive. Keep it in mind. For the slip value should be from varies between 0 to 0.5. In that case only, this negative sequence rotor field speed will be some positive value. Getting my point? So whatever the torque it is going to be acting on the rotor due to the negative sequence, then what will happen? The torque will be the difference between Tp minus Tn. Keep it in mind. Whenever the slip varies from 0 to 0.5. Next, second case. For a slip value 0.5 less than equal to S less than equal to 1. Nothing but what? Slip it is going to be varies between 0.5 to 1. So in that case, what will happen? The net torque, it will be the add up the positive sequence torque plus negative sequence torque itself. Getting my point? So this is the figure for the motor speed torque characteristics. Getting my point? Then one more important thing is there. So a large dip in the torque which is going to be occurs at the half synchronous speed. Half synchronous speed means 50% of the synchronous speed. If it is there means the larger dip in the torque occurs. In that case, what will happen? Extreme case of rotor unbalancing occurs. Okay. So in this torque, whatever in this torque developed by the machine at a slip of S is equal to 0.5, nothing but 50% synchronous speed, it will be 0. Getting my point? So these are the two cases what we had considered, and this is the speed torque curve with respect to what? Unbalanced rotor impedance. Getting my point? The overall we can say that the unbalanced rotor impedance results into a pulsating type of the torque with the initially 0 average values. The presence of this negative sequence components will reduces what? Motor torque. If the motor torque capability reduces means obviously the copper as well as the core losses are going to be increases. If the losses has been increased means what will happen? Efficiency of the motor or a life of the induction motor, it is going to be reduces. So this is the main impact. So the impact on the motor performance. Getting? So I hope this is clear to all of you. Thank you.